Uh, Hello all, welcome to the session on MCP series. So this is the third video in the MCP series. So in the previous sessions, let us recap what you have done in the previous sessions. So we started with MCP, where M is for model, C for context, and P for protocol. So in the previous session, we had almost gone through what is a model. So we have gone through the architecture of large language model, how it has been evolved over a period of time, and the internal details, how they have been developed by using transformer architecture and also the neural network. So we have not gone into much of the details, but we have given an overview of how these LLMs are evolved in the past 5, 6 years. Then next, we are planning to look at C, which is context, right? Which is context, which is very significant part of MCP. But what I thought was before getting to the context, I would like to have a practical session on how do you access these LLMs models, right? Which are already trained. So that is where we are looking at in this video. We will look at LLM inference. So this is basically a practical session. You can also go through a lab where it involves executing some instructions, some Python notebook, in order to understand what is LLM inference altogether, and what are the tools that are involved in this LLM inference process. So first of all, before getting into the LLM inference, what is inference? So we have seen that in the previous class where a model, which is LLM, is an architecture. So you feed the data, right? In the internet, you have a humongous data available that in the internet that you feed to the LLM, then you get an output, right? And so for the first time, the LLM may not understand the language or the grammar or the structure of English from the data sets. So it needs multiple iterations, multiple loops based on the output. So based on the output, you can see whether the LLM understood or recognized the patterns in the input text, right? So if the output is not matching, so you will do multiple iterations so that LLM understands and entire grammar of an English. So and then it can able to generate the new text. So this phase is called training, right? And which involves adjusting the parameters of the model. So we have seen what are the parameters for a neural network architecture. So once this is done, this might take several weeks to months. The training involves a lot of computations, a lot of GPUs, right? So once the LLM is trained, so then you will deploy into the production, right? So where it is available for consumption for the public or any customer, any user. So now user can ask a question and it can generate the answer. So this is inference. When it is available for usage, uh, right, for consumption, it is called inference. And this is in LLM inference. So this is training. You can also say pre-training. And once the pre-training is done, maybe you can also use fine-tuning, right? Some models are instruction fine-tuned so that if user says that summarize this text, so LLM understand that instruction and it gives the answer as a summary of the input text. And all this is referred to as LLM inference, right? So now you look at the inference pipeline. Now, in order to do this inference, the things that are required are, so when you give a text, now we are talking about inference through program, not through an application, not like a chat GPT. The chat GPT is already available platform where user can give a request and the request automatically sent to the LLM. So that inference is application-based inference. Now we are talking about programmatic inference. So that means we are writing our application like ChatGPT, a mini scale of ChatGPT, and then we will do the inference to the LLM. So for this, you need to understand the program, and And this pipeline involves, first step is in the pipeline, which is called tokenization, where the input given by the user, the text, is decomposed into tokens, or in other words, words. So the text is decomposed into words. In fact, a word is also decomposed into tokens. One word may decompose into one or two tokens, right? You can say the three-fourth of a word is a token. And all these tokens, right, convert into numeric representations, because as we know, a model is a mathematical model. It cannot understand the text. So text has to be converted into numeric representation. And this numeric representation will be sent to the model, which is called, which a phase called forward pass, right? And in this forward pass, the numerical representation goes through a heavy lifting of computations. All the mathematical stuff happens here, magic happens here, and it output as a numerical text, numerical representation. And this numerical representation has to be decoded, because human cannot understand the numerics. So this decode phase will translate or transform the output numerical representation into human readable text. This is called decoding phase. And you can also control the model behavior in terms of how many tokens you require as an output. So you can constrain the output tokens, the number of tokens that are there, number of words in the output. Uh, and the good news is that you don't need to do all the stuff. There's an ecosystem called HuggingFace ecosystem that we are going to discuss in the uh, coming up points. That is called pipeline. So the pipeline is a pre-built library, a pre-built interface where you can use for performing tokenization, forward pass, and decode. You don't need to do all this stuff, because pipeline abstracts away all this process, all these steps, right? So you don't have to worry. So we'll use the pipeline infrastructure here. And then the main thing that is required here is the Hugging Face ecosystem, right? Hugging Face ecosystem, where it has these components. There are four components at high level. One is, it is a model hub in the sense. So whenever any developer or any company that trains a model LLM, and it can keep this model into the Hugging Face ecosystem. So in the Hugging Face ecosystem, you can find thousands, hundreds, thousands of models that are available in this hub, right? You can think of it as a AI GitHub, right? What is a GitHub? So in GitHub, all the projects source code is available, right? So that you can download the source code, you can try it out, you can practice, you can compile, execute, everything you can do. You can play around the source code. So similarly, Hugging Face is a GitHub repository or a hub repository for all the models, LLMs. So once you have access to the Hugging Face, you can download that model, and then you can play with those models at your, right. All these models are available at your disposal. Now, HuggingFace also provides transformers library. So as we know, all LLMs underlying architecture is transformers. So if the tokenization or any other steps, right, the forward pass, everything happens through transformers architecture, where we have looked at the encoder decoder components in the previous session, if you recall. So now Hugging Face provides all the Python-based transformer library. So you can import the transformers, you can make API calls for performing all the phases, including tokenization or including the pipeline phase that we have discussed above. And another thing is datasets hub. There are more curated datasets that are available in the Hugging Face, so that you can use these datasets either for training or for evaluation purpose. So you can access many datasets, publicly available datasets in the Hugging Face. So all the deep learning is based on dataset, right? This is also we have discussed in the previous sessions. And Hugging Face also provides spaces where you can deploy your machine learning models for inference and all other stuff. So this is spaces. So essentially these four components. We will see how to access this Hugging Face, right? So this is one of the prerequisites. We'll look at this prerequisites for the setup. And also we need a Google collaboratory environment. So For any LLMs, you actually need a something called computation, right? GPU. So this GPU may not be available on your local machine. It could be laptop or desktop. Thanks to Google Colab, so a they have provided a platform where you can access free GPU on the basis of cloud, and also it provides a interface, development interface, which is called Jupyter interface, right? Jupyter notebooks or Jupyter Lab notebooks. So you'll see that interface as well. And yeah, Colab, if you have a Gmail access, you can simply create, uh, you can go to, this is called colab.research.google.com. So, so this is how it looks like, colab.research.google.com. So you can log in through Gmail and you can connect to the cloud. So right, then you can execute your Jupyter based Python notebooks. Okay. So that is Colab. And then next is HuggingFace account. So you're supposed to have an account that should be created on the HuggingFace platform. And also you need a token. And this token, once you create account, you can create a token as well. And this token is important for accessing LLMs for models, because some of the models are gated, right? What I mean to gated is that some models are not available for direct access. So you need to request the access for the provider so that the provider looks at your token and then provides the access to your LLM, this LLM. Because that is essential, because some providers need to track how many users are accessing my models. So for tracking purpose, so they also use for this audit. There are a lot of other, and also they want to make sure that the models are not used for unethical purposes. So ethical considerations also required. So that is gated models. So for this you need a token. So if you go to the huggingface.co.join, right? Let me show this. So you can go to huggingface.co.co/join. So where you can give your email address and password. So you can create a new account using this Hugging Face access. Right? Once you create the account, just perform all the registration formalities and also get authenticated. Right? Then you can go to the LLM. So this is the LLM that we are going to make use of for our inference purpose. And this Meta Llama, which is the provider, Meta company, right? And then the name of the LLM is Llama 3.2 3B Instruct. So Llama is the LLM name and 3 is the version, and 3B stands for parameters. So it has 3 billion parameters, right? 3 billion parameters. And it is instruct. It means that the model has been fine-tuned for instruction following. So, right, so that it understands if you ask, if you want to do summarization, or uh, if you want to do any other stuff like any other inferences, question answers, right? So it has been instruction fine-tuned. So even so that you can go to the model Llama 3.2 3B instruct. This is the link. So once you log in here, so you can, there is a provision to request for access, right? So and the access is automatically approved. It doesn't take much time, hardly half an hour, 1 hour. Some are immediate access, right? So that is the gated model, access in the gated models. Next, you get into the Hugging Face tokens. So you need a token, Hugging Face token. This is essentially required for login to the Hugging Face hub via program. So go to the Hugging Face tokens. So there is user access token. This is my access token. So you can navigate to this create new token. So once this token is created, you need to copy the token and save it on your machine, because it's a one-time access. right? So once the token is available, so now we have everything. Colab is available, and Hugging Face platform, we all the prerequisites that are required for our LLM inference. Next simple thing is that you need to understand what is the prompt. So prompt essentially, uh, this is the question, define large language models. So if you want to pass this question to the LLM, so we can construct prompt like this. You'd say the prompt is the user, the role of the uh, LLM inference is user, and this is the content. So this is a Python dictionary where the key is role, content is, value is user, and another key is content, value is define large language model. So this entire stuff is a very simple prompt, very basic prompt that you will be supplying to the while LLM inference. So this is all the setup. Now we'll get into the notebook. So I already have this notebook, MCP Lab 1, Llama 3.2 3B instruct IPY So this is the interactive Python notebook file, right? So I already logged in using my Gmail, and this is the first thing. So you can install and upgrade a transformers library. So it will be installed from the Hugging Face Hub. As I mentioned, Hugging Face Hub provides transformers Python library, right? So I already installed earlier, so it says requirement already satisfied. So for your first, if you're running this for the first time, so it will install all the packages that are part of transformers library. Next, we'll go into the inferencing on local inference on GPU. So first, before accessing to the LLM, which is available on Hugging Face, so you are supposed to log in from Google Colab. This is the platform is Google Colab. So Google Colab doesn't know what is Hugging Face, right? So uh, you just have to log in through Hugging Face. So we are in Google Colab, running the program, Python program, and this Google Colab needs to access to the Hugging Face hub. For this, you need to pass either token, right? We already created the token. And yeah. Now, if you run this, it will prompt for Hugging Face token. The secret Hugging Face token does not exist in your Colab secret. So you need to, once you click this, it will prompt for the Hugging Face in a text box. So you can provide this token in the text. So once you're logged in, now this is important stuff. So this is what I am referring to the pipeline. So here, this pipeline will make sure the input text is tokenized and it performs a forward pass. It also decodes, right? Everything has been done in this pipeline infrastructure, a pipeline workflow. So first parameter is text generation. So we are using this LLM for this task. So text generation is the basically task. What are the other tasks that are required, available? So you can also do text summarization, right? So, or you can do question answers. So there are other tasks, various tasks that are involved in this pipeline. But for now, we are using text generation. Next parameter is model. So in the model, as I mentioned earlier, we are going to use Meta Llama. And this is a Llama 3.2 3B instruct model, which is already available in Hugging Face Hub. Right? And next parameter is device map. Usually device is that either you should mention it as a CPU or GPU, right? So CPU is it's not that performant computationally. That's not highly performant. Whereas GPU, which is available as part of this Google Colab, you can make use of the Google Colab GPU. Or you can say auto. When you say auto, the ecosystem, the Google Colab ecosystem will access either CPU or GPU based on the availability and based on the requirement of the computation stuff. So you don't need to worry about the selection of the processor. So when you mention auto, it takes automatically. And then return full text is false. So I don't want to get any other output parameters. I just want only uh, the answer from the LLM. Max new tokens 500. This is the output tokens. We are keeping a restriction on the output number of words that are uh, provided by the LLM, right? And do sample equal to false. We'll discuss this parameter also. This is basically which controls the randomness of the output. We'll see that also uh, in the next sessions. So next is setup prompt message. This is a simple prompt that we already discussed. The user role, where we want to get an answer for this content, define large language model, right, from the LLM. So output equal generator dot message. So this is where the actual inference happens. This is where actual uh, all the mathematics happens, the tokenization and the computation stuff, the forward pass stuff, right? And then decoding stuff. Everything happens here. So once you get output, so you can also print the output. I just printed output. It is basically it's a dictionary where the key is generated text and output is an answer. And you can also use this print form. So directly print the generated text, right? Because this is a dictionary, you can access this key as a generated text, uh, and it gives the value. So this is a readable answer from LLM. So this is the definition of LLM. That is from the LLM, the meta LLM. Now you can control this output. As I mentioned, you can say, let's say if you want to see the written full text equal to true, we'll see the difference. Let me run this thing. So I think once again it is downloading the model from HuggingFace Hub. This might take some time. So once you run this pipeline, the Colab will connect to the HuggingFace, and it locates this model, Llama 3.23b instruct, then it loads that model. And device set to use CUDA. This is basically GPU device. So as I mentioned, auto, so it is using this device. Next, run the messages, generate the output. So this also might take some time because this is where all the magic happens, as I mentioned, right? So it just performs the tokenization and then get to the forward pass, right? And then you'll output. Yeah. Now if you print this output, there's a difference, right? Now you can see even the input is also as part of generated text. This is the content, this is the role, and this is the content, which is answer. And this content is from the assistant. When you say assistant, your LLM is the assistant, right? So now you can see the full text. So when you say full text equal to true, written full text equal to true, it provides input as well, input prompt as well. Now you print generated text, now it looks something different, right? So you need to change the dictionary in order to just get the generated text. So this is the one parameter, written text, and then you can also increase the tokens, right? If you get 800 tokens, right? This is also can be done. And do sample is for randomness. I'll explain probably in next session because it involves multiple parameters where you can control the temperature, top K, top P, right? Uh, I'll explain this thing. When you say randomness, there are parameters like temperature, and you also have top K and top P. So with these combinations, you can control the answer, diverseness, or in other words, randomness of the output. For example, if you ask a question, how are you? The answer is, I am fine, right? Uh, Very restricted answer. If you want to diverse answers, like I am good, I am okay. Every time you ask a question, every time you ask the same question, how are you? You are expecting a different answers. I am okay, I am fine, I am good, I am doing good. So in that case, you need to adjust this temperature parameters, top key. Otherwise, it gives a greedy answer. So I think that might be overloaded for this session. So in other words, yeah, this is the prompt. This is all LLM inference. Because if you understand this LLM inference and this setup required for this LLM inference, HuggingFace, Colab, right, transformer library, then we'll get into the context. In the next video, we'll go into the context, right? Because context is a significant aspect of MCP, where you need to understand all these prerequisites. So I think that's all for this session. So you can get this notebook and then you play with these parameters and let's see the variations of the output, right? So that's all for this session. Yeah. Thanks for watching this video.